Question 11 says a particle is moving along a straight line from west to east with a constant velocity 40 meters per second as shown in the figure. For an observer sitting at O, the angular velocity of the particle at the instant theta is equal to 30 degree will be. It is given that the perpendicular separation is 80 meters. So this is given. Now dear students, if this value is y and this value is x, we can write down that tan theta here will be equal to x by y, and therefore further differentiating with respect to time, we can write down that sec square theta d theta by dt will be equal to dx by dt into 1 by y. Please note here that y is a constant which is 80 meters, so this will be equal to v by y. Now the students, d theta by dt here will be equal to v by y into cos square theta. In the given question, y is given to be equal to 80 meters, v is given to be equal to 40 meters per second, and theta here it is given to be equal to 30 degrees. So we can substitute all of these values in this expression and find out the value of d theta by dt, that will be 3 by 8 radian per second, and this is the required angular speed. It means that the option number 2 of this question is the correct answer. Now proceeding to the question number 12. Question 12 is a fairly theoretical question. It says that consider a particle moving uniformly on a circular path. Then which among the following is correct? First option says that the differentiation of the position is constant. Dear students, it is incorrect, as the differentiation of position means velocity, and velocity in case of uniform circular motion continuously changes direction. So this is an incorrect statement. Second option says that d velocity by dt is constant. Dear students, the rate of change of velocity is equal to the acceleration, and in the case of uniform circular motion, the acceleration is always directed from the particle to the center, that is the centripetal acceleration. Though the centripetal acceleration does not change in magnitude, it does change in direction, and therefore option number 2 is also incorrect, as the centripetal acceleration cannot be said to be constant. Now statement 3 says that the rate of change of speed is constant. This is actually true, because the velocity's direction may change, however its magnitude remains constant, which means the differentiation of the magnitude is 0. Therefore dear students, the correct answer for this question is option number 3. Now moving on to the question number 13. Question 13 says the particle is projected from ground with an initial velocity of 18√3 meters per second. Then the time taken by the particle in moving from P to Q is. Dear students, let the velocity of the particle at P be v. Because the horizontal component of the velocity remains constant, we can write down that v cos 30 will be equal to 18√3 cos 60. And on solving this, we can find out the value of v, that will be equal to 18 meters per second. Dear students, in this question, if you see clearly and very attentively, you can see that P to Q is itself a small projectile. And all we need to do is to find out the time period of this projectile. The time period of this projectile will be equal to 2v sin theta by g, where v is 18 meters per second, theta is equal to 30 degrees, and g, as in the question is given, is 10 meters per second square. On substituting these values, we get a value of capital T to be equal to 1.8 seconds, meaning that for this question the correct answer is option number 1. Now moving on to the question number 14. Question 14 says that consider a square ABCD of side 1 meter each as shown in the figure if OA vector plus AB vector plus BD vector will have a magnitude of. Dear students, OA vector plus AB vector plus BD vector can be written as OA vector plus AB vector plus BO vector plus OD vector. And we can see that OA vector plus AB vector plus BO vector will be 0, because they form the closed triangle as just marked in the figure. So this will be equal to 0, and hence this will be equal to OD vector. Now dear students, the magnitude of OD is actually half of the diagonal. So that will be half of diagonal, that is √2, and therefore the magnitude of this vector addition will be equal to 1 by root 2 meters, meaning that for this question the correct answer is option number 4. Now let us proceed to the question number 15. Question 15 says that the most precise instrument among the following is. Dear students, the precision will be high for the instrument for which the least count is minimum. And for this question, the minimum least count is for the screw gauge as in option 2, that is 0.001 millimeter, and hence the answer for this theoretical question is option number 2. Now moving on to the question number 16.